My name is Kira O'Neill, and today we're going to be talking about Pascal's triangle, its application to mathematics, and its history. So, to begin, what even is Pascal's triangle? Pascal's triangle, pictured at the right, is a triangular arrangement of numbers that gives the coefficients and the expansion of any binomial expression. However, we will come to discover that it has a lot more uses in addition to this. In many ways, that definition leaves us with more questions than answers. How are we supposed to build this thing? How do we know which coefficients go with what? Well, to build Pascal's triangle, you simply add the two numbers from the previous row into the next one. At the edge of each row is an imaginary zero, which allows you to further build out your triangle. And eventually, voila, you've now made your very own Pascal's triangle. So now that we've made this triangle, let's go back to what on earth we're supposed to do with it. The largely accepted main purpose of Pascal's triangle is to expand binomials. First, let's look at the structure of an expanded binomial. Within each term, the exponential values of the two components must add up to the exponential value of the initial binomial. These exponential values also decrease or increase by 1 each time as you go across the page. Now, pick a coefficient of one of these terms and notice how it aligns with the exact same term in Pascal's triangle. Pascal's triangle can also be used to solve combination problems. The combination of one number onto another directly corresponds with their placement in Pascal's triangle. Now, both of these concepts are quite a bit easier to understand with an example, so why don't we try a simple problem together? So, say for example you were asked to expand the binomial a plus b to the fifth. So first you would form Pascal's triangle in the way that we all discussed before. One helpful tip is that you only have to form Pascal's triangle to the row that corresponds with the exponential value that the binomial is being held to. Now, create the skeleton of the binomial expansion. Now apply the coefficients to your expansion. And bam! You've now fully expanded a plus b to the fifth. Combination problems are usually even easier because they don't require full expansion. Take this example where you're asked to find the possible teams that can be formed from a 3-person team of a 5-person pool. To solve this, you simply grab the third term from the fifth row of Pascal's triangle and bam! 10 teams can be formed. Now at this point, you're probably wondering who even came up with this stuff. And that is a more complicated question than you might think. The first known formation of what we would now call Pascal's triangle was by Mary Prestara in the 2nd and 3rd century BC in India. Now, this is not the most well-documented source, and some people like to give credit to other scholars in creating Pascal's triangle. Largely, this is due to the fact that Mary Prestara did not use his staircase of Mount Meru, as it was later called, to find solutions to binomial expansions. Instead, he used it to solve combination problems. Now that, combined with the poorly documented nature and age of his work, led it to be an incredibly important but largely forgotten part of Pascal's triangle's history. Now, this may have you wondering, who did discover the relationship between Pascal's triangle and binomial coefficients? Well, the first person to do so was a 10th century Persian mathematician Abu Bakr Muhammad ibn al-Husayn al-Karaji. Now, al-Karaji contributed quite a bit to the study of mathematics and especially algebra. A now lost work of his contained a tablet-style version of Pascal's triangle, and al-Karaji was the first person to connect this configuration with the coefficients of a binomial expansion. However, none of his work was really popularized in Iran before Omar Khayyam. Khayyam was an 11th century Persian mathematician who greatly popularized this original triangle. In many areas of modern-day Persia, this triangle is referred to as Khayyam's triangle instead of Pascal's. Now, incredibly similar work was also being developed independently in China right around this time. The 11th century Chinese mathematician Jia Xian was the first man to develop the relationship between the binomial expansion coefficients and a triangular shape in his area. On a global scale, his impact was being the first to develop the modern shape of Pascal's triangle, which more clearly shows the relationship between the coefficients than previous triangles. Similarly to what occurred in Persia, his work was largely popularized by the 13th century Chinese politician Yang Hui. For this reason, many people in China still refer to this concept as Yang Hui's triangle. So, at this point, the natural response to all this information is, why on earth is this called Pascal's triangle? He was like the last person to discover it. And this holds true even regionally within Europe. Many European mathematicians had already published about this triangle, including Jordanus de Nemours in the 13th century. Pascal's contribution was certainly not in his discovery of the triangle, but rather his popularization and standardization of it. In Pascal's treatise, Traité des triangles arithmétiques, he consolidated other European mathematicians' work. He also independently developed the application of the triangle to combination problems. So, what does all this even mean? Well, Pascal's triangle is an incredibly important mathematical tool, but it also in many ways serves as a symbol. When we think of symbols in math, we probably think of an addition or a multiplication sign, but Pascal's triangle takes on a different form of the word. There is something really beautiful about a bunch of different humans being able to come to the same conclusion completely independently from one another. The different discoveries, and popularizations, and work done with Pascal's triangle reflect an innate human quest for creativity and knowledge. They show that even people whose lives are so completely different that they were born centuries apart from one another, they still are connected by ideas like math and science. However, Pascal's triangle also serves as a symbol of concern. It's concerning that the concept was given the name of the person who popularized it in that region, and not the person who discovered it. It's also concerning that the non-Western names who largely discovered the idea first are not used as widespreadly as the name Pascal. Well, Pascal's triangle certainly gives you a lot to reflect on. I hope you learned something in this video and want to say thanks so much for watching, and I hope you have a great day. Bye!